Tonight, we uncover the terrifying possibility that the Big Bang was not the birth of everything, but a violent mask hiding a much older, much darker cosmic history. For a century, we have comforted ourselves with the story of a beginning. We've been told that 13.8 billion years ago, a single, infinitesimal point of infinite heat and density erupted, creating space, time, and everything you've ever loved. It was a clean, linear narrative that fit perfectly into our textbooks. But in the last few years, that narrative hasn't just been challenged, it has been systematically dismantled. We sent a 10 billion daylight-sensitive mirror into the deep black of the Lagrange point, expecting to see the universe in its infancy. Instead, we found something that shouldn't exist. We found grandparent galaxies in a universe that was supposed to be a nursery. We found heavy elements forged in the hearts of stars that hadn't had time to be born yet. And suddenly the word beginning started to feel like a placeholder for a truth we were too afraid to see. We are no longer looking for our origins. We are performing a forensic reconstruction of a cosmic crime scene, searching for the fingerprints of whatever reality was murdered so that our own could exist. The story of our modern crisis begins not with a whimper, but with a word that no scientist ever wants to use when describing the foundations of reality: bananas. When the James Webb Space Telescope, a gold-coated marvel folded like origami and launched 1 million miles from Earth, finally opened its eyes, it wasn't just looking further into space, it was looking further into a past we thought we had already mapped. The scientific community had spent decades perfecting a framework called Lambda CDM, the standard model of cosmology. It was a beautiful, precise machine that told us exactly how the universe grew. First the heat, then the cooling, then the first atoms, and only after hundreds of millions of years of patient gravitational tugging, the first stars and galaxies. It was a slow, orderly assembly line of existence. But the data that started streaming back from the edge of time didn't just require a footnote, it demanded a structural rethink of everything we thought we knew. At redshifts where the universe was supposed to be a chaotic, foggy soup of hydrogen, Webb found galaxies that were fully formed, massive, and eerily mature. These are what researchers now informally call impossibly early galaxies. They are leviathans appearing in a period so early in cosmic history that according to our best models, they simply did not have enough time to exist. Think about the scale of this error. For a galaxy as massive as our Milky Way to exist, when the universe was less than 700 million years old, star formation would have had to proceed with an efficiency of nearly 100%. Every atom of gas in those regions would have had to instantly collapse into a star without a single breath of waste, a process that violates every simulation we've ever built. Erica Nelson, a tenured astrophysicist, looked at this data and told the world it was bananas because there is no other word for a reality that refuses to follow its own rules. But the banana galaxies were only the first crack in the glass. When the spectroscopic data arrived, the chemical fingerprints of that ancient light, it revealed something even more disturbing. In galaxies that existed when the universe was barely 1 billion years old, we found carbon and oxygen. In our current timeline, heavy elements like these are only forged in the death throes of stars. They require generations of stellar life and supernova explosions to seed the cosmos. Webb was showing us a universe that was already chemically evolved, already structured, and already old at its supposed birth. It's as if you walked into a room that was supposedly built 5 minutes ago, only to find the walls covered in ancient dust and the furniture worn thin by centuries of use. This isn't a fringe debate happening in the corners of the internet. This is a paradigm pressure building at the heart of institutions like Cambridge and MIT. Physicists are beginning to admit that the part of the model describing what happened after the Big Bang, how quickly structure formed, and how efficiently gas collapsed, is fundamentally broken. We are forced to consider a possibility that feels like an existential weight. Perhaps the universe didn't start from zero. If the structures at the edge of time are too mature for their age, then perhaps they didn't have to start from scratch. Perhaps they are the memory echoes of a previous cycle, or debris escaping from a parent universe that existed before our own. The standard model rests on two pillars we have named but never actually seen: dark matter and dark energy. They make up 95% of our universe, yet every attempt to detect them in a lab has returned a haunting, hollow silence. We have built our entire history of the cosmos on these invisible placeholders, and now the most expensive mirror ever built is showing us that even within that framework, the timeline doesn't fit. We made the Big Bang feel like settled history, a linear timeline on a classroom wall, safely understood and filed away. But Webb has pointed a mirror at our assumptions and showed us that the math doesn't add up. We are living in what scientists call a placeholder situation, a region of the map where we are forced to write, "Here there be things we cannot explain." The telescope isn't broken, the universe is just older in its complexity than we were prepared to admit. We are realizing that our definition of the beginning might just be the limit of our current vision. We are staring at a singularity firewall, a mathematical wall of silence where our equations fail, and we have mistaken that silence for a birth. But as we peer through the cracks in the lambda CDM model, we see hints of something far more vast and far more ancient. The impossibly early galaxies are the first clues in a forensic investigation that will take us beyond the firewall into a reality where the Big Bang was just a single heartbeat in an eternal, recursive life. If the universe was already complex a few 100 million years after its supposed start, we have to ask the question that keeps cosmologists awake. What was it doing in the time we claimed didn't exist? We are about to discover that the smoke and ashes we live in may belong to a fire that has been burning forever. The problem with seeking the truth about our origin is that every path we take eventually leads us to a wall. We call this wall the Big Bang, but in the private offices of theoretical physicists it has a much more unsettling name: the singularity. For decades we've treated this moment as a literal beginning, a point where a clock started ticking in a void of non-existence. But as we push our understanding to the absolute edge, we are discovering that the singularity isn't a physical event we can observe, it is a mathematical scream. When we try to calculate the state of the universe at time zero, our equations don't just give us the wrong answers, they descend into a terrifying, total mathematical silence. To understand the depth of this crisis, you have to understand what a singularity actually is. In the language of Einstein's general relativity, the most successful map of reality we've ever drawn, the universe is expanding. If you play that expansion in reverse, everything in the cosmos, from the furthest quasars to the atoms in your own skin, begins to converge. It gets hotter, denser, and smaller, until the entire observable universe is compressed into a space smaller than a single proton. But when you try to calculate the density and the temperature of that point, the numbers don't just become large, they become infinite. In mathematics, infinity is not a number you can work with. It is a signal that the system has crashed. It's the equivalent of a computer trying to divide by zero. It doesn't tell you what happened, it simply stops providing information. This is the singularity firewall. It is a horizon of total ignorance beyond which human knowledge collapses. We have spent a century telling ourselves that this mathematical crash was a birth, but that is a dangerous assumption. Imagine trying to use a compass to find your way to the North Pole. As you get closer, the needle works perfectly, guiding you with precision. But the moment you stand directly on the pole, the concept of north vanishes. Every direction you look is south. The question, what is north of the North Pole, isn't just difficult to answer. It is a malformed question that the compass is incapable of processing. The singularity is our cosmic North Pole. It is the place where our current laws of physics wink out, leaving us standing in a void of data. This mathematical silence is the result of a civil war between the two great pillars of modern science. On one side you have general relativity, which governs the vast, heavy structures of the universe, stars, galaxies, and the fabric of space-time itself. On the other, you have quantum mechanics, which rules the chaotic, vibrating world of the subatomic, Normally, these two theories never have to meet. One handles the big, the other handles the small. But at the moment of the Big Bang, the big and the small became the same thing. You had the mass of an entire universe crammed into a subatomic speck. In that environment, both theories demand to be heard, but when you try to combine them, they refuse to speak the same language. They produce mathematical silence because we lack a unified theory, a quantum gravity, that can bridge the gap. Because of this, many physicists are beginning to pivot toward a radical new perspective. They are suggesting that the singularity isn't a physical beginning at all, but rather evidence of incomplete mathematics. We have mistaken a no-entry sign for a creation event. Just because our current map of reality ends at a certain coordinate doesn't mean the territory itself stops there. When ancient cartographers reached the edge of the known world, they didn't assume the ocean fell into an abyss. They simply wrote, "Here be monsters," because their tools could go no further. The singularity is the "here be monsters" of modern cosmology. Perhaps the most haunting piece of evidence for this shift comes from the very men who proved the singularity existed in the first place. In 1970, Stephen Hawking and Roger Penrose published a series of theorems that seemed to confirm once and for all that the universe must have started from a point of infinite density. It was the day without yesterday that the world's textbooks still teach to this day. But toward the end of their lives, both Hawking and Penrose began to disavow their own conclusions. They realized that their proof relied on assumptions that were almost certainly wrong, specifically the assumption that general relativity is a complete description of the universe at all scales. When we remove the firewall of the singularity, the entire story of our existence changes. If the singularity is just a mathematical artifact, a glitch in our current equations, then there is no reason to believe that time started 13.8 billion years ago. We are realizing that the Big Bang may not have been an explosion of nothing into something, but a transition point. It was a moment where the universe became so dense that our current physics broke, hiding whatever came before it behind a veil of corrupted data. This realization is both exhilarating and deeply disturbing. If there was no beginning in the way we understand it, then we are living in a universe that is far older and perhaps far more complex than we have the capacity to imagine. The impossibly early galaxies we are seeing with our telescopes aren't just anomalies, they are the first echoes reaching us from across the firewall. They are the grandparents of a reality that was supposed to be a newborn nursery. We are no longer looking at the dawn of time, we are looking at the smoke rising from a fire that may have been burning for an eternity. The singularity isn't a wall that protects us from the before, it is a mask. And as we begin to pull that mask away, we find ourselves staring into a forensic reconstruction of a cosmic crime scene. We are searching for the fingerprints of the reality that existed before our own, scars left behind on the fabric of the universe that our equations were never supposed to find. If we want to know the truth about our origin, we have to stop asking what happened at the Big Bang and start asking what happened through it. We have to find the memory echoes of a prior cycle, the subtle patterns in the cosmic background that suggest our beginning was actually a rebound from a much older, much darker history. The firewall is starting to crumble, and what we're finding on the other side is a universe that never truly began at all. To continue our forensic investigation, we must look at the only piece of physical evidence we have left from the dawn of time, the light that has been traveling toward us for 13.8 billion years. This is the cosmic microwave background, or the CMB. In every textbook, it is described as the afterglow of the Big Bang, a snapshot of the universe when it was just 380,000 years old. But if we are to treat the Big Bang as a transition rather than a beginning, we have to stop looking at the CMB as a baby picture and start looking at it as a crime scene. When we look at the sky in microwave frequencies, we see a speckled pattern of tiny temperature fluctuations. Most scientists see these as the seeds of future galaxies, regions where matter was slightly denser, destined to collapse under gravity. But there is a growing controversial movement in physics that suggests these speckles aren't just random static. They are cosmic scars, physical fingerprints left behind by a reality that existed before our own. The lead investigator in this cosmic cold case is Sir Roger Penrose, a Nobel Prize-winning physicist who refuses to accept the mathematical silence of the singularity. Penrose argues that if the universe is cyclic, if it expands, dies, and is reborn, then the most violent events of the previous universe should leave a mark on the next one. He points to something the standard models ignore: concentric circular patterns hidden within the CMB data. To understand what these circles are, you have to imagine the end of a previous universe. In the far, far future, all stars have burnt out, and only supermassive black holes remain. Over unimaginable eons, these black holes eventually collide. When two monsters, each billions of times the mass of our Sun, spiral into each other and merge, they release a burst of gravitational waves so powerful they literally shake the fabric of space-time. Penrose's theory, conformal cyclic cosmology, suggests that these gravitational bursts are so intense they can actually survive the transition through the Big Bang. When our universe rebounded or reset, the echoes of those ancient black hole collisions were imprinted onto the primordial plasma. They appear to us today as these subtle, concentric rings of temperature. They are the gravitational echoes of a world that was murdered to make room for ours. While many mainstream cosmologists are skeptical, claiming these patterns could be statistical flukes, Penrose and his team insist the signal is there. If they are right, it means the CMB is not a picture of a beginning. It is a forensic record of a prior aeon's death throes. But the evidence doesn't stop with circles. There are other anomalies in the CMB that the standard model struggles to explain. Features like the cold spot, a vast region of the sky that is significantly colder than the rest of the radiation. For years, we've tried to write it off as a random fluctuation, but in the context of a cyclic universe, the cold spot looks less like an accident and more like a bruise. It could be the site of a brain collision, a point where our universe physically bumped into another reality or where the collapse of the previous cycle was particularly violent. We have been taught that the early universe was a state of perfect simplicity, but the fingerprints we are finding suggest a level of inherited complexity. The impossibly early galaxies we discussed might only be possible because they were seeded by these ancient scars. If the previous universe left behind regions of higher density or gravitational fossils, then the first stars didn't have to wait for random fluctuations to build galaxies from scratch. They were born into a landscape that already had a memory of structure. This changes our entire relationship with the cosmos. We aren't living in a brand new house. We are living in a reconstruction built on ancient foundations. The hiss that Penzias and Wilson first heard in their antenna in 1964, the sound we've called the birth cry of the universe, might actually be the muffled scream of a dying one. As we peer deeper into these patterns, we find ourselves staring at a singularity firewall that is starting to leak. Our equations might fail at time zero, but the physical universe seems to have remembered what happened. We are finding that the Big Bang didn't erase the past, it merely translated it into a language of radiation and gravity that we are only just beginning to decode. The deeper horror of the forensic investigation is the realization that if we can see the scars of the previous universe, then our own universe is currently creating the scars that will be inherited by the next one. We are a single link in a chain of existential recursion, and the beginnings we cling to are merely the moments when the ink of reality was still wet enough to be smudged by the past. We must confront the possibility that space and time are not a one-way street, but an infinite loop where the far future and the distant past are the same coordinate. The forensic fingerprint tells us that we are not the first to stand here, looking up at the stars. We are simply the latest version of a story that has been told countless times before, written in the cold, faint light of a background that refused to be silent. In this light, the James Webb Space Telescope's discovery of impossible galaxies is no longer a mystery to be solved, but a confirmation to be accepted. They are the structural remains of a prior age, survivors of a cosmic reset that couldn't quite clear the board. We are living among the ruins of the before, and the deeper we look, the more we realize that our time is merely a brief interval in an eternal, recurring life. The fingerprints are there, etched into the sky, waiting for us to admit that we were wrong about the beginning. To understand how the universe survived its own collapse, we have to look past the curves of gravity and into a hidden, mechanical tension that Einstein himself chose to ignore. For a century, we've been told that gravity is the undisputed master of the cosmos, a force that curves the fabric of space and time like a heavy ball resting on a trampoline. In this standard version of the story, gravity is an insatiable glutton. As the universe contracts, gravity only grows stronger, pulling matter closer and closer until everything is crushed into that impossible zero-volume point of the singularity. But there is a growing movement of physicalist theorists who argue that this story is incomplete because it treats space-time as if it can only bend and never twist. They suggest that the secret to our existence lies in a property called space-time torsion. In the early 20th century, while Einstein was perfecting the math of curvature, a mathematician named Alie Cartan pointed out a glaring omission. He suggested that space-time doesn't just have a shape, it has a torque. In the standard equations of general relativity, torsion is set to 0, mostly because it makes the math easier and because, in the vast, empty reaches of the modern universe, twisting forces are nearly impossible to detect. But when you move toward the extreme densities of the Big Bang, ignoring torsion is like trying to describe a car engine while ignoring the tension in its springs. To visualize this, stop thinking of space-time as a flat sheet of fabric and start thinking of it as a physical material, something more like a heavy industrial sponge or a massive coil of steel. When gravity pulls matter inward, it isn't just curving the sponge, it is wringing it out. As the previous universe collapsed toward its end, the geometry of space began to twist with a violent, helical energy. This is the torsion twist. At normal densities, this twist is negligible, but as you approach the firewall of the singularity, the torsion begins to act as a repulsive physical force. Imagine a massive, high-tension spring being compressed by a hydraulic press. At first, the press moves easily. The spring offers little resistance, but as the coils are forced closer together, the internal tension of the metal begins to scream. There comes a point where the spring cannot be compressed any further. Its physical structure becomes stiff and incompressible. This is exactly what torsion does to the fabric of reality. At the highest imaginable densities, the twisting of space-time creates a geometrical stiffness that gravity cannot overcome. It creates a physical flaw, a minimum compression point. This moment is the most violent event in the history of existence. It is not a singularity where the math stops, it is a minimum compression point where the universe hits its limit and recoils. Instead of collapsing into a point of zero size, the stiffened space-time triggers a massive outward rebound. The hydraulic press of gravity fails, and the spring of the universe snaps back with a ferocity that we have mistaken for an explosion from nothingness. This is the torsion bounce. What we call the Big Bang was actually the recoil of a universe that refused to be crushed. The bang was the sound of the spring releasing its energy. This changes the narrative from a mystical creation event into a mechanical necessity. It means the universe has a built-in safety valve, a geometric law that prevents the total annihilation of information. In this framework, the Big Bang wasn't the birth of the universe, it was a transition of state, a violent reset, where the kinetic energy of a collapsing world was converted into the heat and expansion of our own. The implications of this are profoundly disturbing for our current understanding of time. If the universe has a minimum size, then it has never been nothing. There was never a moment of non-existence. Instead, the universe is like a cosmic piston, endlessly cycling between compression and expansion. But the torsion bounce adds a layer of stiffness that suggests each cycle is not a perfect copy of the last. The twist preserves a memory of the previous collapse. When we look at the most distant galaxies through the James Webb Telescope, we might be seeing the direct result of this mechanical rebound. If the universe didn't start as a smooth, infinitesimal point, but rather bounced back from a highly structured, twisted state, it would explain why the early universe appears so mature. The structure didn't have to grow from scratch, it was shaken into existence by the torque of the bounce. The impossibly early galaxies are the debris of this mechanical recoil, formed in the high-pressure environment of a space that was already stiff with the tension of its previous life. This mechanical view of the Big Bang removes the need for godlike creation and replaces it with the cold, hard logic of geometry. It suggests that the universe is a self-regulating machine, one that uses the very act of collapse to fuel its next rebirth. We are living in the expansion phase of a recoil that is still happening. The galaxies flying away from us aren't just moving, they are being pushed by the residual tension of that ancient spring, still unwinding after billions of years. But if the universe is a spring, we have to ask, what happens when the tension finally runs out? If torsion forced the bounce, what happens when the expansion eventually slows? Standard cosmology suggests we might expand forever into a cold, dark void. But the torsion twist introduces a more cyclical, perhaps more haunting possibility. If the geometry of space can twist to force a bounce, it can also twist to facilitate a return. We are not just moving away from a beginning, we are being propelled toward the next compression. The Big Bang was not a singular miracle, it was a physical rebound, a moment where the stiffness of reality reached its breaking point and fought back. We are the children of that recoil, living in a brief moment of slack between the twist of the past and the inevitable torque of the future. The mathematical silence of the singularity was never the truth, it was just the sound of our equations hitting the coils of a spring they weren't designed to measure. Now that we know the spring is there, we have to face the fact that the universe didn't just start, it fought its way into being. If the universe is a machine, we have to ask where it is housed, and for that answer, we must look beyond the three dimensions we call home and into a reality that exists outside the borders of our perception. Until now, we have treated the Big Bang as an internal event, a spring snapping or a fire igniting from within. But a radical theory proposed by physicists Paul Steinhardt and Neil Turok suggests that the bang was actually a touch, the violent, high-energy impact of two vast, higher-dimensional membranes colliding in a space we cannot see. This is the ekpyrotic theory, and it transforms the history of everything into a rhythmic, eternal, cosmic heartbeat. To understand this, you have to discard the idea that our universe is the total of reality. Instead, imagine that we live on a three-dimensional island, a brain, floating in a vast, higher-dimensional ocean called the bulk. In this higher dimensional space, our universe is just one of many, drifting like a sheet of paper suspended in a void. But we are not alone in the bulk. Floating parallel to us is another brain, another universe invisible and unreachable by light, yet excitive of a powerful, ghostly gravitational pull. For trillions of years, these two universes drift through the bulk, slowly drawn together by a hidden interbrain force. As they approach, the tension between them builds, storing an unimaginable amount of potential energy. They do not collide at a single point. They impact across their entire surfaces simultaneously. This is the ekpyrotic pulse. When these two worlds touch, the kinetic energy of their collision is instantly converted into the fire and matter of what we perceive as the Big Bang. In this framework, there is no singularity. There is no mathematical silence where the laws of physics stop working. The density and temperature never become truly infinite because the collision happens over a finite, albeit incredibly short, period of time. By avoiding the singularity entirely, the ekpyrotic model solves the firewall problem that has haunted cosmology for a century. The Big Bang was not the moment time began. It was simply the moment two higher dimensional worlds made contact. But the most haunting aspect of this theory is its rhythm. The collision isn't a one-time accident. After the brain's impact, the energy of the collision pushes them apart. They move away from each other, expanding and cooling, creating the universe we see today. Stars forming, galaxies drifting, and life emerging in the slack between pulses. But the force that drew them together in the first place never disappears. Eventually, the expansion slows. The brains reach their maximum distance, stop, and begin the long, slow crawl back toward one another. This is the cosmic heartbeat. Reality is not a linear timeline. It is a cycle of impact, expansion, contraction, and impact again. Every Big Bang in our past was just the latest thump of this multidimensional heart, and every big crunch in our future is merely the preparation for the next beat. We are currently living in the exhale of a collision that happened 13.8 billion years ago, drifting in the quiet expansion before the inhale begins. This theory offers a disturbing explanation for why our universe is so eerily smooth and flat. Standard cosmology requires a period of inflation, a magical, faster-than-light growth spurt, to explain why the sky looks the same in every direction. But the ekpyrotic model suggests that the smoothness didn't come from a sudden burst of growth. Instead, it was ironed out during the long trillions of years before the collision as the two brains slowly drifted toward each other. The uniformity we see in the cosmic microwave background is not a relic of a frantic beginning, but a memory of the long, cold peace that preceded the last pulse. This changes the way we look at the James Webb Space Telescope's discoveries. The impossibly early galaxies aren't just an anomaly of our timeline. They might be the direct result of the collision's geometry. If the brains didn't hit perfectly flat, if they were slightly rippled, the first regions of contact would have ignited matter earlier than others. We are seeing a universe that was born with a structure already dictated by the shape of the higher dimensions that birthed it. The ekpyrotic theory forces us to confront a terrifying sense of existential recursion. If our universe is just one brain in the bulk, then the Big Bang was not a unique miracle. It was a local event, a recurring heartbeat in an infinite multidimensional ocean. We are not the protagonists of a grand creation story. We are the temporary foam produced by the collision of two much larger, much older realities. And the most chilling realization is that this heartbeat is eternal. There was no first collision, and there will be no last. The brains have been dancing in the bulk forever, endlessly touching and retreating, sparking infinite Big Bangs and wiping away infinite civilizations with every pulse. As you sit here, the inhale may have already begun. The invisible world parallel to ours is starting its long, slow return. We cannot see it, we cannot feel it, but the math suggests it is there, drifting through the bulk, coming to deliver the next violent touch that will reset our history and forge the next aeon from the ashes of our own. We are living in the silence between heartbeats, and the next one is inevitable. The Big Bang wasn't the beginning. It was just the last time the universe took a breath. If we are to accept that the Big Bang was not a beginning but a transition, we must look for a mechanism that doesn't just reset the clock, but actually creates the space and time we inhabit. To find it, we have to turn our gaze away from the edge of the visible universe and toward the dark, hungry monsters lurking in our own galactic backyard, black holes. For a century, we have viewed the black hole as the ultimate graveyard, a place where matter, light, and information go to be erased from existence. But in the private journals of theoretical physicists, a far more radical, almost biological picture is emerging. They are suggesting that the singularity at the heart of a black hole is not a dead end, but the flip side of a very familiar coin. If you look at the math of a black hole's singularity and the math of the Big Bang's origin, they are nearly identical. One is a point of infinite collapse, the other a point of infinite expansion. This has led to the haunting realization that we might be looking at the same event from two different sides. The Big Bang wasn't a random explosion in a void, it was the birth cry of a new universe erupting from the other side of a black hole in a parent cosmos. This is the theory of the fractal universe, and it suggests a reality that is nested like a set of infinite Russian dolls. In this framework, every time a massive star in a parent universe collapses into a black hole, it doesn't just crush matter into nothingness. Instead, as that matter reaches the impossible densities of the singularity, it tunnels through the fabric of space-time, creating a new region of space, a baby universe, that expands outward into its own dimensions. To an observer in the parent universe, it looks like a black hole, a dark, static sphere of no return. But to an inhabitant inside that black hole, it looks like a Big Bang, a sudden, violent influx of energy and matter that creates a brand new sky. This means our entire observable universe, with its billions of galaxies and trillions of stars, might be tucked away inside a single event horizon, floating in a much larger, much older mother universe that we can never see or touch. But the mystery goes deeper than just simple geometry. If universes are born from black holes, then reality itself might be subject to the laws of biology. This is the groundbreaking proposal of physicist Lee Smolin, known as cosmological natural selection. Smolin noticed a glaring problem in physics that has haunted the field for generations: the fine-tuning problem. If the physical constants of our universe, the strength of gravity, the mass of an electron, the force that holds atoms together, were even slightly different, stars wouldn't form, atoms would fly apart, and life would be impossible. For decades, we've been told this was either an incredible stroke of luck or evidence of a designer. But Smolin suggests a third option: our universe is fine-tuned because it inherited its traits from its parents. In Smolin's Darwinian multiverse, universes reproduce through the creation of black holes. When a new universe is born from a black hole, it inherits the physical laws and constants of its parent, but with a tiny genetic mutation, a small variation in the fundamental numbers of physics. Now consider the logic of evolution. A universe that has laws which prevent the formation of stars will never create black holes. Because it never creates black holes, it never has offspring. It is an evolutionary dead end. However, a universe with laws that are perfectly tuned to create massive stars will produce millions of black holes. Each of those black holes becomes a seed for a new baby universe that inherits those same star-forming laws. Over unimaginable eons of cosmic generations, the multiverse becomes overwhelmingly populated by universes that are exceptionally good at making stars and black holes. We are not living in a lucky universe. We are living in a highly successful one. Our universe is fine-tuned for stars and complexity not because of a miracle, but because it is the descendant of a long line of high reproducers, universes that were masters at collapsing matter. This adds a layer of existential recursion to our story that borders on horror. It suggests that the beginning we have worshipped for so long was merely a reproductive event in a cosmic ecosystem. We are part of a fractal lineage of realities, each one birthed from the womb of a dying star in the world that came before. This also offers a chillingly elegant explanation for the impossibly early galaxies found by the James Webb Telescope. If our universe was birthed from the collapse of a parent cosmos, it didn't necessarily start from a clean slate of nothingness. It may have inherited a blueprint of complexity from the parent black hole. The matter and energy that flooded into our Big Bang wasn't random. It was the debris of a pre-existing reality, compressed and refired into a new configuration. This would mean that the mature galaxies we see at the edge of time aren't anomalies. They are the first structures to form because the universe was born with a memory of how to build them. But there is a darker side to this black hole womb theory. If every black hole in our sky is a gateway to a new universe, then we are currently in the process of birthing millions of offspring of our own. Every time a star dies in the Milky Way and collapses into a singularity, we are witnessing a Big Bang for a reality that will never know we exist. We are the ancestors of an infinite chain of nested worlds, just as we are the offspring of a parent we can never find. The singularity is not a wall, it is a birth canal. And the most disturbing realization is that we might be debris escaping from a parent that is still, even now, consuming matter from its own sky to to fuel our expansion. We have spent centuries looking for a single, divine first cause, but the math of black hole genesis suggests there is no such thing. There is only the cycle of collapse and expansion, a fractal web of life where the death of a star is the only way a universe can truly begin. We are not the center of the story, we are just one generation in a multiverse that has learned how to survive its own end by hiding its children inside the very thing that was supposed to destroy them. The singularity firewall isn't there to stop our knowledge, it is the protective shell of the womb, and the mathematical silence we hear is just the quiet before the next birth. We were wrong about the Big Bang because we were looking for a creator when we should have been looking for a parent. For decades, we have lived with the grim certainty of a one-way universe. We've been told that the engine of expansion, a mysterious, invisible force called dark energy, is a permanent, unchanging property of space itself. In this standard version of the future, the universe is a runaway train. Dark energy acts as a kind of anti-gravity, pushing galaxies apart at an ever-accelerating rate until every star is isolated in a private, frozen void. We called this the heat death, the ultimate cold end of everything. But in 2025, a new piece of technology called the Dark Energy Spectroscopic Instrument, or DESI, sent a shockwave through the scientific community by suggesting that the cosmic engine might be running out of fuel. The forever expansion we were promised is not a law of nature, it's a temporary phase, and the implications for our cosmic history are nothing short of revolutionary. To understand the scale of the DESI crisis, you have to understand the placeholder we call lambda. In the standard lambda CDM model, dark energy is treated as a cosmological constant, an energy density that never changes, never decays, and never evolves. It was the push that would eventually win the war against the pull of gravity. For 25 years, this was the bedrock of cosmology, a Nobel Prize-winning fact of life. But DESI was built to map the sky with a precision we've never before achieved, surveying the positions and light of millions of galaxies and quasars across billions of years of history. And when the researchers analyzed the first 3 years of data, they didn't find a constant, they found a decline. The DESI results indicate that dark energy's influence has actually weakened over the last few billion years. Instead of a steady, relentless push, the repulsive effect of space seems to be decaying or evolving. It's as if the universe's accelerator pedal is slowly being lifted. This is what theorists call evolving dark energy, and it is a structural rethink of the entire cosmic timeline. If dark energy is not a constant, then the heat death is no longer a certainty. We are moving from a universe of eternal isolation to a universe that might be capable of taking an inhale. This shift in data reopens a door that many scientists thought was closed forever. The door to the Big Crunch. In a universe where dark energy remains constant, expansion is eternal. But if dark energy continues to weaken, there will come a point where its outward push is no longer strong enough to resist the collective inward pull of all the matter in the cosmos. Gravity, the insatiable glutton we discussed in earlier chapters, would finally regain control. The expansion would slow, it would stop, and then, for the first time in 13.8 billion years, the universe would begin to contract. Imagine the sheer scale of that reversal. The galaxies that have spent billions of years flying away from us would begin to turn back. The smoke and ashes of our current universe would start to converge, falling back toward a central, unimaginably dense state. This is the Big Crunch, the ultimate mirror image of the Big Bang. As the universe contracts, the temperature rises, the structures we know are shredded, and everything is funneled back into that high-pressure, minimum compression point we explored through the lens of space-time torsion. This is the missing link in our cycle. The DESI data suggests that the Big Bang was not a unique one-off event because the engine of our current expansion has an expiration date. If the universe eventually collapses, it sets the stage perfectly for the next torsion bounce or the next ekpyrotic pulse. The Big Bang we live in today was likely sparked by the decay and collapse of the universe that came before us. We are not living in a linear story of growth. We are living in the exhale of a cosmic breath that is already beginning to slow down. The crisis of dark energy is only a crisis if you are wedded to the idea of a single, linear beginning. If you accept the recursive nature of the cosmos, then the weakening of dark energy is the most hopeful news humanity has ever received. It means the universe is not a sterile, dying void, but a living system with a pulse. It suggests that the heat death, that terrifying eternity of cold and silence, is a mathematical error born from our assumption that things never change. But there is a haunting psychological weight to this discovery. If dark energy is dying, it means our era of the universe, the era of stars, planets, and observers, is a fleeting window of stability between two violent collapses. We are the temporary foam produced by a rebound, living in the brief interval of slack before the universe is reabsorbed into itself. The James Webb Telescope showed us galaxies that were too mature because they were born from the debris of a prior collapse, and now DESI is showing us that our own expansion is losing its grip, preparing us for the collapse that will birth the next aeon. We have mistaken the accelerating expansion for a permanent state, but it may just be the final thinning push of a spring that is finally losing its tension. As dark energy evolves and decays, the forever expansion model fails, and the standard model of cosmology begins to look like a description of a single, local weather pattern rather than a law of the entire multiverse. We are realizing that the Big Bang was a transition, and the Big Crunch is the inevitable return. This is the true forensic reconstruction. Every piece of data, from the impossibly early galaxies seen by Webb to the weakening push measured by DESI, is telling the same story. The universe is a cycle. The beginning was a rebound, and the end will be a reset. We were wrong about the Big Bang because we thought it was a start, but the dying energy in the deep black of space is telling us that it was just a beginning of an interval. The mathematical silence we heard at time zero was the sound of our universe preparing for its next breath. And as the engine of our current age begins to fail, we must face the reality that we are part of a history that is much older, much darker, and far more eternal than we ever dared to believe. To understand how our future becomes our past, we must travel to the absolute end of time, a period so distant that the numbers used to describe it have more digits than there are atoms in the observable universe. If the weakening of dark energy doesn't trigger a big crunch, the standard model dictates a much lonelier fate, the heat death. Trillions of years from now, the last stars will flicker out, trillions more, and the black holes themselves will evaporate into a faint haze of Hawking radiation. Eventually, even the matter that makes up your body, the protons and neutrons we thought were eternal, may decay into nothingness. We are left with a universe that is cold, dark, and utterly featureless, a void containing nothing but a thin, stretching soup of massless photons and gravitons. In this state of ultimate entropy, we encounter the most profound paradox in cosmology. For a century, we have viewed this heat death as the graveyard of reality. But Sir Roger Penrose, the man who proved that singularities must exist, has proposed a theory that transforms this graveyard into a nursery. This is conformal cyclic cosmology, or CCC. It suggests that when the universe reaches its absolute featureless end, it forgets how big it is. And in that moment of cosmic amnesia, the end of one universe becomes the Big Bang of the next. To grasp this, you have to understand the concept of scale. In our daily lives, we measure the world with rulers and clocks, but a ruler only works because it is made of atoms, and atoms have a specific size dictated by the mass of their particles. A clock only ticks because it has a physical mechanism that moves through space over time. However, in the far, far future of the heat death, there are no atoms, there are no rulers, there are no clocks, there is only radiation, particles like photons that have no mass. In the world of physics, massless particles are special They don't experience time, and they don't see distance. If you were a photon, the entire history of the universe would happen in a single, instantaneous flash, and the entire expanse of the cosmos would have no measurable width. When the universe contains only massless particles, the very concepts of large and small lose all physical meaning. The universe becomes scale invariant. This is where Penrose's mathematical genius takes a turn into the surreal. He uses a geometric trick called conformal rescaling, inspired by the recursive, infinite art of M.C. Escher, to show that an infinitely large, cold, and thin future is mathematically identical to an infinitely small, hot, and dense beginning. Imagine looking at an Escher print where the edges of the circle represent infinity, but as you move toward them, the shapes get smaller and smaller, yet remain perfectly proportioned. Penrose argues that at the end of time, the universe squashes its own infinity. Because there is nothing left to define how big the universe is, the state of maximum expansion rescales itself into the state of a new Big Bang. In this narrative, the Big Bang was not a moment of creation from nothingness. It was a conformal transition, a geometric handoff between one aeon and the next. We are living in just one aeon in an infinite vertical chain of universes. The beginning we have spent billions of dollars trying to see was simply the moment the previous universe reached such a state of emptiness and scale invariance that its geometry snapped into a new, hot explosion. This solves the greatest problem in cyclic cosmology, entropy. Usually, the law of entropy states that disorder must always increase, which would mean that every successive universe should be more messy and chaotic than the last, eventually making life and stars impossible. But Penrose's CCC suggests that during the transition between aeons, the mess of the previous universe, the entropy, is effectively washed away because the information that defined the disorder loses its scale. The transition acts like a cosmic filter, allowing the universe to reset its entropy and start fresh, while still carrying forward a few terrifying scars. This brings us back to the forensic investigation of the cosmic microwave background. If CCC is correct, then the most violent events of the previous aeon should have left a mark that survived the transition. Penrose and his team claim to have found these marks, concentric rings in the CMB radiation that they believe are the gravitational echoes of supermassive black holes colliding in the universe before our own. These rings are the muffled screams of a dying world, etched into the very fabric of our starting point. The implication of aeons of entropy is that the universe is not a story with a plot. It is a symphony that repeats forever. There was no time zero because time is a property that emerges from the scale of the aeon we happen to be in. When the scale vanishes, time doesn't stop. It simply resets its rhythm. We have mistaken the boundary between two aeons for a wall of creation, but we are starting to see that the firewall is transparent. This view of the cosmos is both quietly beautiful and existentially chilling. It suggests that our entire history, every war, every discovery, every breath, is just a temporary fluctuation in a state that will eventually return to featureless radiation, only to be reborn again. We are not moving toward a final conclusion. We are moving toward a transition. The heat death is not the end of the book. It is the moment the ink dries on one page and the next page begins to turn. We were wrong about the Big Bang because we assumed the universe had to have a beginning, but the math of entropy and scale suggests that existence may be a closed loop of geometry. The end and the beginning are not two different points. They are the same coordinate, viewed from different sides of a conformal mirror. As we look out into the cold, expanding void of our own future, we aren't just looking at our demise, we are looking at the preconditions for the next Big Bang. We are looking at the nothingness that will eventually forget its own size and explode into a new sky filled with new stars and perhaps new observers who will one day look back and wonder, just as we do, where it all began. They will find the rings we are leaving behind today, the forensic evidence of our collisions, and they will realize that their beginning was our ending. To solve the mystery of our origin, we must finally confront the most stubborn illusion of the human mind, the idea that time is a straight line. We have spent this journey looking for a before, a parent universe, a mechanical spring, or a multidimensional collision. But every one of those theories still relies on a first cause, a starting point that requires its own explanation, leading us into an infinite and exhausting regression. To break this chain, we must consider a possibility that defies every intuition we've ever had about cause and effect. We must entertain the idea that the universe does not have a beginning because it is a self-creating loop, a temporal serpent that exists only because its own future reached back to birth its past. For decades, the most prestigious answer to the time zero problem was the no-boundary proposal championed by Stephen Hawking and James Hartle. Hawking realized that as you approach the Big Bang, the conditions become so extreme that our very definition of time begins to fail. In this state, the fourth dimension, the one we experience as a relentless forward arrow, undergoes a radical transformation. It begins to behave like a spatial dimension. To visualize this, Hawking used the now famous metaphor of the South Pole. If you are standing at the South Pole, you cannot go further south. But this isn't because you've hit a wall or a singularity firewall. It's simply because the geometry of the Earth has curved in such a way that south no longer exists as a direction. In the same way, the no-boundary proposal suggests that as you trace the universe back to its origin, time itself rounds off like the bottom of a sphere. There was no moment of the Big Bang because time didn't exist in a linear way yet. Asking what happened before the Big Bang is as meaningless as asking what is south of the South Pole. The universe just is. It is finite in its history, yet it has no edge, no beginning, and no creator. But even the no-boundary proposal feels like a mathematical dodge to many. It removes the beginning, but it doesn't explain why the sphere exists in the first place. This is where Richard Gott and Li-Shin Li introduced an idea that pushed cosmology into the realm of existential vertigo, the self-creating universe. They proposed that the universe didn't just round off at the start, it actually looped back on itself. In Einstein's general relativity, there are certain rare and controversial solutions to the equations called closed time-like curves. These are paths through the fabric of space and time that literally curve back to their own starting point. If you were to travel along a closed time-like curve, you would eventually find yourself arriving at the exact moment you departed. It is the ultimate cosmic version of Groundhog Day, but instead of a single man trapped in a small town, it is the entire multiverse trapped in a recursive cycle of birth. Gott and Lee argued that in the high-energy chaos of the early universe, a branch of the inflationary multiverse could have curved back through a closed, time-like curve to become its own trunk. This is the self-creating loop. In this framework, the universe is its own mother and its own daughter. The far future of the cosmos, perhaps trillions of years from now, literally provides the gravitational and inflationary spark that triggers the Big Bang in its own past. This transforms reality into a closed temporal circle. It eliminates the need for nothingness to ever exist. The universe exists today because it has always existed in a loop, endlessly creating itself in a moment that is simultaneously the end and the beginning. It is a day without a yesterday, not because time started there, but because time is a circle that has no room for a yesterday outside of itself. This perspective offers a mind-bending solution to the impossibly early galaxies and the fine-tuning mysteries we've encountered. If the universe is a self-creating loop, then the structures we see today are not the result of a random explosion. They are the inevitable prerequisites for the universe's own survival. The galaxies had to form, the stars had to die, and the black holes had to collapse because those events were the very things that provided the energy and the blueprint for the Big Bang that created them. The universe is fine-tuned for life because only a universe that produces complexity can eventually loop back to ensure its own birth. But the psychological horror of the self-creating loop is the realization of total cosmic entrapment. If time is a closed circle, then every event in our history is not just recurring, it is fixed. Every star that explodes, every world that dies, and every choice you make is a necessary gear in a machine that is perpetually birthing itself. We are not moving toward an unknown future. We are moving toward the very moment we've already been. The Big Bang was not a birth, but a reunion, a point where the snake's head finally meets its tail. As we look at the data from the James Webb Telescope, we might be seeing the literal ghosts of our own future. The maturity and complexity at the edge of time aren't anomalies. They are the structural requirements of a universe that has already lived its entire life and is now reaching back to make sure it happens again. We have been looking for a creator in the deep past, but the math suggests that the creator is us, or rather, the version of us that will exist at the end of the aeon. This leads us to the final, most disturbing chapter of our investigation. If there is no before, no nothingness, and no start, then we have been asking the wrong question for 10,000 years. We have been obsessed with how the universe began, when the real mystery is why we are so terrified of a universe that simply is. We are about to confront the death of beginnings, the moment where we stop looking for our origin and start realizing that we are trapped in an eternal, beautiful, and terrifying recursion. The firewall of the singularity was never a wall, it was a mirror. And as we look into it, we are finally seeing our own reflection staring back at us from the other side of time. We have spent 10 chapters dismantling the most comfortable story humanity ever told itself. The story of a beginning. We are a species obsessed with the first page of the book. Our human psychology is wired for clear origins, for a moment where a clock started ticking and a void of non-existence was suddenly filled with light and purpose. We made the Big Bang feel like settled history, a linear timeline on a classroom wall that was safely understood and filed away. We did this because an absolute beginning is legible. It gives us a boundary, a place where our history starts and our responsibility to the before ends. But as we have seen, that linear timeline was never a law of nature. It was a psychological shield we used to protect ourselves from the terrifying vastness of eternity. The beginning we have worshipped for a century was merely a placeholder for a truth we were too afraid to see. We treated the singularity as a literal birth, but in reality it was a singularity firewall, a mathematical wall of silence where our current equations simply stopped providing information. We mistook the limit of our vision for the edge of reality. Now, as the data from the James Webb Telescope shows us grandparent galaxies in a universe that was supposed to be a newborn nursery, we are forced to admit that our day without yesterday was just a chapter in a much older, much darker cosmic history. We are realizing that the Big Bang may have been an exit from a previous world rather than a birth into this one. In this forensic reconstruction of the cosmos, we are discovering that modern cosmology is accidentally rediscovering ancient cyclic mythologies that humanity has carried in its blood for millennia. Long before the first particle accelerator was built, the Hindus, Stoics, and Buddhists envisioned a universe that went through endless cycles of creation and destruction. The Norse spoke of Ragnarok, the final battle where the world is consumed by fire, only to rise again green and fertile from the ashes of the old. Modern science, through theories like Penrose's conformal cyclic cosmology or the ekpyrotic pulse, is effectively recreating these archetypes. We are finding that the fire and matter of our Big Bang may be the result of a higher dimensional collision or the recoil of a torsion bounce, a mechanical safety valve that prevents the universe from ever truly disappearing into nothingness. This is the death of beginnings. It is the moment where we stop looking for a first cause and start realizing that we are part of an infinite, vertical chain of universes, each birthed from the womb of a dying star or the conformal transition of a featureless void. If the universe is a self-creating loop, a temporal circle where the far future literally becomes its own past, then there is no time zero. There is only the rhythm of the cosmic heartbeat, an eternal cycle of impact and expansion that has been beating forever. The mathematical silence we heard at the Big Bang was not the silence of a beginning, it was the quiet before the next birth. We must now confront the realization that our definition of time is a local feature of our particular bubble of space-time, a property that only becomes meaningful once the universe has cooled enough to crystallize into something with a direction. Outside of our local aeon, the concepts of large and small, before and after, may lose all physical meaning. We are living in the exhale of a collision that happened 13.8 billion years ago, drifting in the brief interval of slack before the inhale begins again. The impossibly early galaxies are the structural remains of that prior age, survivors of a cosmic reset that couldn't quite clear the board. We are living among the ruins of the before, written in the cold, faint light of a background radiation that refused to be silent. This leaves us trapped between two terrifying possibilities, neither of which offers the comfort of the textbooks we grew up with. Either everything you see, every star, every galaxy, every memory you have ever held, emerged from absolute, literal nothingness in a miracle that violates every law of logic we possess, or existence has no beginning at all. In the second scenario, the universe is an eternal, recursive machine that never truly started because it has always been, endlessly creating itself in a closed temporal circle where death is merely a transition instead of extinction. The firewall of the singularity was never a wall, it was a mask, and as we pull it away, we find that we are staring into a mirror. We are a collaboration of ancient explosions, the temporary foam produced by a rebound, and we are likely just one generation in a multiverse that has learned how to survive its own end by hiding its children inside the very things meant to destroy them. The universe is 13.8 billion years old, and we have only been asking questions for the last tiny fraction of that time. We are just getting started, but the deeper we look, the more we realize that the answer we are searching for isn't at the beginning. The answer is that the beginning is a myth, and we are simply the latest version of a story that has been told countless times before. We were wrong about the Big Bang because we were looking for a creator, when we should have been looking for the fingerprints of an eternal life that refuses to die.